Hello and welcome to another video. In this video, we're actually going to skip the first two problems of the biweekly contest because the first problem is basically this with easier constraints, and the second problem is pretty easy, so we're going to do the third and the fourth one. So in this one, we're going to be doing count the number of incrementable subarrays 2. And in the problem, you're given a zero index array of positive integers nums. A subarray nums is called incrementable if nums become stringently increasing on removing the subarray. For example, the subarray 34 is an incrementable subarray because removing the subarray changes it to strictly increasing. Return the total number of incrementable subarrays of nums. Notice an empty array is considered strictly increasing. A subarray is contiguous, non-empty sequence of elements within an array. So in this first one, they show like what are all the things you can remove. So for example, if you remove the 1, that is strictly increasing. You can also remove 1, 2. You can also remove 1, 2, 3, 1, 2, 3, 4, and so on, right? So you can remove these 10 different combinations. In the second one, you can't quite remove everything. For example, you can't remove something like the 5 because that wouldn't be strictly increasing. So you can remove, actually you can remove the 5, sorry. You can't remove something like the 7. So like this would be strictly increasing, so you could remove the 5, you can remove the 6, you can remove this chunk, 5, 7, 8, 6, 5, 7, and 6, 5, 7, 8. And in the third one, it's even less stuff that you can remove because it's way out of order. So you can remove something like 8, 7, 6, you can remove the whole thing, and you can remove, 7, 6, 6. So how are we going to do this problem? And to do this problem, we're going to define like what we like when we remove things. What do we need to have an array strictly increasing? So let's do that. So when we remove some chunk, what do we need to have the array be strictly increasing? And we need to kind of figure out a way to do this pretty quickly because this is 10 to the 5th, so we need like an n log n or an n time solution. So we can have 3 scenarios for removal, and you can actually handle them all at the same time, but if you want to have no space complexity, I'm going to actually have them separately. So one scenario is remove chunk from the right. And what do we need for that to be strictly increasing? Like, let's say we're over here and we're going to say we're just going to chop off this whole thing from the right, right? We're going to remove the whole thing from the right. What do we need to have our chunk be, like, what do we need to have the rest of the array be strictly increasing? Well, it's pretty easy, right? Whatever index we're on, whatever we remove, we need this index to be strictly increasing, right? We need everything up until here to be strictly increasing. So we can write that down as well. So for this to be good, the remainder needs to be strictly. It actually needs to be strictly decreasing. And let me show you why. So if we remove, like let's say we're on this index and we remove this, it needs to be strictly decreasing starting at this number, right? So this number needs to be the like biggest number. And that's how we're going to do it. So there's a difference between strictly increasing and strictly decreasing, right? Like this part, if you start here, is going to be decreasing. But if you start here, let's say, then this part is strictly increasing. So we're going to keep that separate. So we're going to say, yeah, that's what we need. Okay, now the other thing is we can remove from the left, right? So we can remove chunk from the left. For this to be good, the remainder needs to be strictly increasing. And like I said, I mean strictly increasing or decreasing from whatever index we pick, right? So let's say we pick here. If we remove this, then starting here, this needs to be strictly increasing, right? Similarly, if we move from the right, then starting here, going this way, this needs to be strictly decreasing. So those are 2 ways, and then we have one final way, and that's remove between 2 indices. So for this to be good, index left index or left number needs to be smaller than right number, and left side decreasing, right side increasing. So what do I mean by that? Well, let's look at this. Let's actually try to copy this somehow. Okay, so what I mean by that is, let's say we are at like this index, and we just want to get rid of like this section here. Well, for this to be a valid increasing subarray, this index needs to be less than this, right? Like this value. So this value has to be less. And this part starting here needs to be decreasing. And this part here needs to be increasing, right? And also notice that if we remove, like, let's say we want to remove this section, and this is valid, like in this case it is valid, that means we know that if this part is strictly decreasing, that means we also know that, let's actually draw an arrow here. There we go. That means we know that like this will be valid and this will be valid, right? Because if this is decreasing, then all of these numbers are going to be smaller than this number here, and all of the numbers to the left will be decreasing. So that's the kind of like the important thing to take away is when numbers are decreasing, if it's decreasing starting from here, it's also decreasing starting from here and decreasing starting from here. Similarly, if it's increasing starting from here, that means it's increasing starting from here, increasing starting from here, and so on, right? Because what does it mean if it's increasing starting from here? That means every number past this number will be increasing. So these are the three constraints we need to look for, and two of them are pretty easy, and then the third one's a little tricky. So first of all, let's figure out, and like I said, you can do this, and you can code this on your own if you want to. So what you could do is you can actually put in dummy values like this, and this actually helps with the code a lot. Now you don't need to do these like remove chunk from the right, remove chunk from the left. You can always remove in between two indices and just count these as indices. So like if you wanted to remove the entire subarray, you would remove between these indices and so on. And if you wanted to remove, let's say, anything after 1, you would do something like this now, right? But you can't really do this without these. So without these, you're going to have to do these things separately, but you will get O of 1 space. That's what we're going to go over. So first of all, what we are actually going to do is we're actually going to go through our array, and we're going to write down what's the rightmost element that is strictly decreasing. And what do I mean by that? I mean, like, we're gonna go one by one and keep checking for increasing, and then as soon as it starts decreasing, the element before that is the rightmost element that's increasing. So we can kind of show that here. So like this is the first number, then this is increasing, 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 then it drops here. So this element is the rightmost element from which the array is strictly decreasing, right? Like from here, it's decreasing to the left, from here, it's decreasing to the left, from here, it's decreasing to the left, and so on. So that's what we want to do first, is calculate it. And this is very easy. You just do a for loop, and you just check like for each number and make sure it's greater than the one before, and then store the index of the last one. So we're going to write that down. We're going to write down that index. And let's also index these numbers to make it a little bit easier. So let's just say 0, 1, 2, 3, 5, 6, 7, 8, 9. Okay. So now that we found that, right, this is the index this is the rightmost index where the array is decreasing. So let's put that in. So decreasing is going to be at index 4. Now we can do the same thing. We want to figure out what's the leftmost index where the array is strictly increasing from the right. So we can say like, okay, so far this is the first number, that's fine. Second number, it's still increasing, 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 increasing. And then here's like where it breaks. So everything past this number is strictly increasing. And you can also do the same thing. It's very easy, right? You just go from the right to left, and you just keep checking, like, is the number right after my number greater than it? If yes, then update my index. So the index where it's increasing from is right over here, right? Because like if I start here, it's not strictly increasing from here because it decreases here. So this is going to be the index that I want to mark. And so I'm going to say increasing, and the index will be 6. So now basically what I need to do is I need to handle all of these 3 cases. So let's go over how we would handle all of these 3 cases. Well, if we want to remove a chunk from the right, what it means is like we pick an index and we remove everything from the right. So in order for this to be valid, we need the number and everything to the left of it to be strictly decreasing, right? Like for example, we can't pick like this number and remove from the right because this is not decreasing. So basically what we can do is we can just say, okay, well, if our decreasing index is 4, that means for all of these numbers, if I just remove everything from the right, this will be fine. Like for example, if I pick this index and I say, let's get rid of this, this is increasing. If I pick this index and I say, let's get rid of this, this is increasing, and so on, right? So for this first part, it is just going to be the value of decreasing plus 1. Right? Just how many indices are valid that are strictly decreasing? It's going to be all of these, right? Because this is the last index that's valid. So it's going to be the number of indices plus 1. So that one is fine. Now, obviously, let's say your whole array, you do have to do a small check. If your whole array is strictly decreasing, you would actually get 9 here, right? And you don't want to, you have to actually have a number left. So you just minimize, the most number of indices you can have is n minus 1, right? So you would just do a little check there, just make sure like, okay, if the whole array is strictly decreasing, then it's n minus 1 instead of n. Now, this part, removing chunks from the left, is very similar. We can take any index that is strictly increasing from it, like let's say we pick an index, so our leftmost index is index 6. Actually, this should be index 5. Yeah, it should be index 5. It's a small area there. Okay, so any index here or later, if I pick it, then what we said is anything with that number n to the right of it is strictly increasing, right? So for this index, if I want to just chop off the whole left section, this will always be valid because everything to the right is increasing. For this index, same thing, right? For all of these, for this whole range, this is valid. So you just figure out like how many indices that is. So in this case, we have 5 indices. And like I said, you want to have maximum n minus 1 because you don't want to delete the whole array, right? Let's say this whole thing was strictly increasing. You wouldn't want to delete like, you wouldn't want to actually delete this index, right? So it would be the same kind of idea. You just figure out like how many indices are valid, and that's how many you can delete from. So this is just going to be some kind of calculation. I think this is like length of n or something. So length of n is 10 here. I think it's something like this. I'll have to double check, but something like this. It's just a basic calculation, right? You figure out like where is your first increasing one, and all these are valid. How many are there, and that's how you can delete from the left. So that part is good. Now we have to do this last part, and there is one more section here. So we are deleting from the right. We are deleting from the left. Now there is one more thing, which is delete the whole array. So deleting the whole array will always be valid. So we will just like add 1 here, right? Like we figure out how many we can delete from the left, how many we can delete from the right, and then the whole array is obviously always going to be valid. Like I said, this would infinities would let you handle all of this because, like for example, here you can always do the between case because the whole array in the between case would be this. So it would be actually like this. So if you want to code it up with infinities, like you can actually just put an infinity and negative infinity to the left and right of nums, and this third case will handle everything. But because I didn't want to modify the inputs a little bit trickier. Okay, so now that we know how to get rid of chunks from the left, now that we know how to get rid of chunks from the right, like I said, from the right, everything to the left needs to be strictly decreasing. Everything to remove from the left, the number, and everything to the right needs to be strictly increasing. We have these 2 locations. Now we have to figure out how to actually get the middle parts, right? Like let's say we want to delete, let's say we pick these 2 indices and we want to delete from the middle. And notice that these 2 you can do in O1 because you'll just do a 1 pass to calculate the decreasing index, another 1 pass to calculate the increasing index, and then these 2 you can do in O1 now. Now this part we can't just like pick every 2 indices, right? We can't just be like, let's pick this and this. Let's pick, we can't have an n-squared solution. So what you can actually do is notice that for the indices to be valid, right? For the indices to be valid, the right index has to be in the strictly increasing section. Because when we delete from the middle, like let's say we pick this index and this index, when we delete from the middle, the left part has to be strictly decreasing and the right part has to be strictly increasing still. So the range that we're going to choose to delete from, the right side of it has to be in this like strictly increasing section. We can only delete between one of these indices and something to the left of it, right? because like let's say we try to delete here and here. Okay, we could delete this, but then the problem is this is not strictly increasing, right? So that part is important, so we can write that down. So delete between every index that is increasing, right? Strictly increasing. And so what's the other index that we want to pick? Like let's say we want to delete between this index and some other index. What is the optimal index we want to look for? So the optimal index we want to look for, once again, let's say we delete from like let's say our rightmost decreasing index is here. If we delete from here, this will make it a valid array, right? But notice that because this whole thing is strictly decreasing, right? If this whole thing is strictly decreasing, oh, we also do need to check one more thing, but I'll get into that as well. But if this whole thing is strictly decreasing and there's one more check that we're missing, then we know that everything to the left, like if we pick this location here, so we pick this location, everything to the left will also be valid because this is strictly decreasing, right? So like this will be valid, this will be valid, this will be valid, and this will be valid because that's the last thing we need to do. So we need to delete here, and let's add one more criteria. Delete between and the rightmost. Let's actually move this down ideally, so we don't get rid of space. Whoops. Okay, let's move it down here. And the rightmost strictly decreasing index or location that is smaller than the right one, right? That's our other criteria. So when we pick these two things, so like let's say we pick this number, like if we know that this whole range is strictly decreasing, we can't always pick the right one because imagine our numbers here are like this, right? Instead of this 6, imagine we have 10. Now we can't pick these two because if we delete this, that means this chunk wouldn't be strictly increasing. So that's the other criteria we need. We need the leftmost, we need the rightmost strictly decreasing index that is also smaller than the right index, right? Because we need the remainder to be strictly increasing. So in this case, if this was 10, we can leave it like this. We would say, okay, this is strictly like we're gonna initialize. What we're gonna do is we're gonna binary search basically through our entire decreasing range, right? So we're gonna say, okay, the range we need to search from is here. It's gonna be an increasing range. And then we're going to say, okay, we need the rightmost value that is smaller than this. So what's going to happen is we're going to go here. This is going to be the first value that's valid. And then once we know that this is valid, then we know like this is valid, this is valid, this is valid, right? Because this part is strictly increasing, we know that for sure, right? 0 to 4 is strictly increasing because we calculated that beforehand. That means if we find the rightmost value that's smaller than this, everything to the left of it will also be smaller than this. So as far as subarrays, we have, like let's say this was our value for this index, that means we would know we would have 4 subarrays, right? This one, this one, this one, this one. So once we get the rightmost location, we can write that down as well. So subarrays equals left index plus 1, right? Subarrays that end with this right one. And so we can do like a dry run now of our algorithm and figure out like what we actually need to have for this one. Okay, so first we're gonna figure out like this first part, right? Like we have this decreasing and increasing. So first let's figure out how, like where it is. So for all of these, we can just delete the right, right? So that's 5 subarrays already. Like for example, for this index, we can say let's delete this. For this index, we can say let's delete this, and all of these are new subarray, right? For this index, delete this, and so on. So let's have a result here. So result, so delete from right, we're gonna be able to delete from 5 locations. Now delete from left. So delete from left, we have to figure out like what are all of our increasing indices. It's all of these, and for each of these, we can delete everything to the left, right? For example, for the 9, we can say let's delete all this. For the 8, we can delete all this and so on. So however many we have of those, so we have 5 of those. So we will add 5. And yeah, I don't think you actually need to minimize it now that I'm looking at it with the length of the array, because you're always going to delete from an index. You're never deleting the whole array. So that's the leading chunks from the left. That's the leading chunks from the right. Now we also need to include obviously deleting the entire array. So that's always going to be one there. Now for the rest of it, we just need to, for every single right index, we need to figure out what's the rightmost left index that's valid. So for example, for this right index, and remember, for every single right index, it's actually in the increasing part, because we need the right index to be in the increasing part, we need the left index to be in the decreasing part, and we need the left index to be smaller than the right index. So we'll have another arrow here. And we're going to start here, right? We're always going to start, our bounds are always going to start here. So I'm just going to draw a range here. Our bounds are, this is going to be like when we binary search, we're always going to search through this section because this is our decreasing section. So when we actually find the rightmost value that is smaller than this value, for the 9, it's going to be this one over here, right? So how many arrays is that? Like we're just going to binary search, and then we're going to, that's just like basic binary search. This is going to be the rightmost value that's smaller than this value. So this is index 3. That means we have 4 subarrays here. So we will add 4. Now we will move this index over here. And what's the rightmost index that is smaller than this one? That's this one as well. So we will add 4. Now we will go over here, same index. So we will add 4. Oops. Now we will go over here and same index again. So we will add 4. And finally, this one over here. Now they're the same. It has to be smaller, so it's going to be over here. So we will add 3. So we have 15, whatever this is, right? 16, 20, 30, I think. So we have 30 total subarrays we can remove. I'm not going to show like all of them, but that's essentially what we need to do. Is we need to do these 3 parts, and then we are basically done. Like I said, you can completely get rid of these sections if you just put in infinities, and you just put in infinities here, and then you count infinities as part of your increasing and decreasing sequence. So you would say like the increasing sequence is here, the decreasing sequence is here. Now also there is another part, and you just need to make sure like your indices don't overlap. But I think that'll be handled when you just check your values, right? Because like here the sections don't overlap, but you need to make sure they don't overlap. And you also need to make sure that there's actually like when you're moving from the middle, let's say you're moving, like let's say your increasing sequence is here and your decreasing sequence is here. Let's say this was a 5 and this was like, or let's say instead of this was being, let's change these numbers a little bit. So let's say this number was like 8 and this number was 5 and this was whatever. Like let's say this was all valid. So this would be the right side, this would be the left side. So technically these two would be the locations, but you also need to make sure that between your left and right, there is a gap of at least 1. So when you initialize for your binary search, you need to make sure that like whatever right you picked, you need to make sure that the rightmost value of the left side, there's a gap of at least 1. So you can't put it here, you have to put it right here, right? Because if you put it here, there's nothing to delete. You're deleting between these two. So there's just like a bunch of small checks that you have to do essentially to make sure that your stuff is correct. But that's pretty much the gist of it. And let's take a look at the code. And yeah, I'm just going to go through the code because I didn't want to write it because there's a lot. So I don't want to take too much time. So I actually don't need this line. I had the infinities before, but I don't need that anymore. So basically what I do is initialize this deck is going to be the left or the rightmost index of the decreasing part. And then the increasing is going to be the rightmost index of the increasing part. And this is essentially what we did before, right? So we find the rightmost index of the completely decrementing segment, which is over here. Then we find the leftmost index of the incrementing segment, which is over here. That part's pretty straightforward. Then this is going to be the parts 1 and 2, right? So here is going to be part 1, right, where you're essentially removing chunks from the right. Here is going to be part 2, where you're removing chunks from the left. Like I said, I don't really think you need this. Yeah, I don't really think you need it because I don't think it can ever be too big. But you can double check that, and then you always have the 1 because the empty array is valid as well, right? So then we figure out like what's the right bound of the location that we have, and this is where we need to be. So essentially, the right segment has to be on the third element, meaning like, let's say your array is like this. The right segment can't start here because that would mean the left segment would be here, and then there would be like no gap. So the increasing part has to start on the third element of the array in order for there to be something to delete in the middle, because this binary search essentially handles deleting from the middle. So you just loop through your entire increasing segment up until the third value, and then you just minimize, or you just have the left and right. So left and right is 0, and this part is, like I said, to make sure that there's actually a gap between your right value that you pick and the left value. So there's a gap of at least 2. Then you simply just find the all of these are going to be in the decreasing segment. So you just find the rightmost value that's less than the right side. And then once you get it, you just, whatever that is, you just add whatever index it was plus 1. And I initialized current to -1 because I wanted to make sure that if I didn't find anything, I would just add 0 here. And then you return 0. You run it. So it does work. And yeah, this should be of one space. Like I said, if you want to make this code a lot easier, just put in negative infinities into your nums, and that will handle a ton of this logic for you, a ton of these edge cases. But yeah, it's going to be all for this one. Oh, yeah, let's, I guess we can quickly talk about the time and space. So for the time, it's n log n because we're essentially binary searching from everything on the right to every valid index on the left. And the space is O of 1 now because we actually just manually calculated where the last decrementing location is and where the first increasing location is. Instead of having, I think when I originally did this, I did this with arrays. I realized I didn't need that. And then I also got rid of these infinities in the nums because that's modifying input. But yeah, that's going to be all for this one. Hopefully you liked it. And if you did, please like the video and subscribe to our channel. And I'll see you in the next one. Thanks for watching.